Welcome. The next part is about two chapters, the radicals and the prime factorization. Prime factorization part is basically related to many chapters, the rational numbers, the decimal numbers, and the radicals. Of course, we're going to start with the radicals as an introduction, then mix them together. The radical is basically, if we have a radical containing x power n, basically if we don't have any number written here, it basically means it is 2. So basically this radical means x to the power n over 2. N over 2. So radical 4, for example, if you memorize the multiplication table well, you should know that 4 is 2 to the power 2. So basically radical 2 to the power 2, and it is 2 over 2. 2 to the power 2 over 2, because this means 2. If we have nothing written here, it means 2. So n over 2, n over 2 equals 2. We also know, using the multiplication table, that 8 is 4 times 2, or 2 to the power 3. In simple terms, we should do this. If we have 3 here, for example, then we have 3 over 3, it is also 2. But if we have nothing here, for example, we have radical 8, so it's basically 2 to the power 3, we divide the 2 power 3 part. We divide into 2 times 2 to the power 2. So 2 to the power 2 evacuates without its power, and we are left with radical 2. So this leaves and becomes 2 radical, and the other 2 stays inside, 2 radical 2. We will discuss this in details later on. The second part is about prime factorization. Prime factorization is basically simplifying numbers into smaller prime numbers. How's that? Let's start. Basically, we should know how to divide numbers first. How to know if a number is divided by 2? The number should end with 0, 2, 4, 6, 8. So if the number ends with 0, 2, 4, 6, 8, it is divided by 2. If not, it is not. This ends with 4, so basically this is divided by 2. It ends with 3, it doesn't. 7, it doesn't. 2, it does. 8, it does. Then, if it's divided by 3, the sum of numbers should be divided by 3. The reminder, memorize the multiplication table well, at least from 1 to 10. First of all, add these numbers. 3 plus 4, it is 7. Is 7 divided by 3 according to the multiplication table? No. So basically this is not divided by 3. 5 plus 3, 8. Is 8 divided by 3? No. So basically this is not. 5 plus 7 is basically 12. 12 is divided by 3. It is 3 times 4. So this is divided by 3. 1 plus 0 plus 2 is 3. 3 is divided by 3. So it is true. 5 plus 8 is 13. 13 is not divided by 3. How to know if it's divided by 5? The number should end with 0 or 5. This ends with 4. It's not divided by 5. This ends with 5. It does. Ends with 5. It does. Ends with 0. It does. Ends with 2. It doesn't. Okay, let's start. This is the process of prime factorization. It is similar to the dividing part, but rather we are not dividing by a specific number. We choose the number to divide this number with. So basically, prime factorization means simplifying a big number into smaller numbers. How? Let's start. 48 is divided by which number? It's divided by 2, because it ends with 8. So basically we write 2 here. And then we start the division. How to divide? We divide from left to right. Let's start. 4. How many 2 it has? We know according to the multiplication table that 2 times 2 is basically 4. So the 4 contains 2 2's. So we write 2 here. 8, how many 2 it has? It has 4. Then this number is also divided by 2 because it ends with 4. 2 contains only 1 2. The 4 contains 2 2's. Also 12 can be divided by 2, it ends with 2. The value will be 6. How to divide it? If we should memorize the multiplication table, but let's consider it. 1 can be divided by it. Rather, the whole 12 contains 6 2's. 6 also can be divided by 2. It ends with 6. Actually, it is a 6. This is the same. 2 times 3 is 6. Then we are left with 3 divided by 3 and 1. When we are left with 1, that means we ended the prime factorization process. We write 48 is basically how many 2's? 1, 2, 3, 4. That means 2 to the power 4 times 3. This is 48 written in prime factors, a product of prime factors. Let's write them under the radical. It helps with the radical process. 2 to the power 4 times 3. In order to get numbers out of the radical, they should have the power of this index. This index has no number, so it is a 2 as we said above. So every number that can exit the radical should have a power 2. 3 can't exit because it has a power 1. 2 power 4 is basically can be divided into 2 power 2 times 2 power 2 times 3. So we are left with 2 2's outside the radical. When they exit the radical, the power 2 is removed. So 2 times 2, radical 3. 4 radical 3. Okay? Also, the prime factorization helps us with the rational number parts. 48 is basically 2 to the power 4 times 3. And 24, if we do prime factorization for 24, it is 2 to the power 3 times 3. We're gonna use the power rules. 2 to the power 4 over 2 to the power 3, which means 2 to the power 4 minus 3 times 3 to the power 1 minus 1. This cancels and becomes 3 to the power 0. Anything power 0 is 1. The answer will be 2 to the power 4 minus 3 is 2 to the power 1. So the answer is 2. Thank you for listening.